Dames en here, die akademiese prosesie sal binnekort inbeweeg. U word versoek om asseblief op te staan.
Bomma le bontate, molokoloko wa diruteri o tla tsena mo nakong e kopana. Le kgopelwa go ema. Ladies and gentlemen, the academic procession will enter shortly. You're kindly requested to stand.
By virtue of the authority entrusted to me, I constitute this assembly as a legal congregation of the University of Pretoria. During this assembly, degrees with all associated rights and privileges will be conferred on the candidates whose names appear in the program. You may take your seats, please. I'd like to welcome the Registrar, Professor Nicholson, and the Dean, Professor Erasmus, and the Deputy Dean, Professor Maharaj, chairpersons of schools, heads of departments, directors, emeriti and honorary professors, and other lecturers and their spouses. The Student Representative Council, represented by Ms. Sakile Masemola, who will present the SRC academic colors and honors. And to all our wonderful graduates, all family members, parents, spouses, girlfriends, boyfriends, you are all welcome here to this great University of Pretoria, as well as all our dignitaries present here that we may not be aware of. Today is a joyful day, a beautiful spring afternoon, and I wish you a very warm welcome to this auspicious graduation ceremony of the Faculty of Natural and Agricultural Sciences at this university. I say joyful day because today we celebrate the culmination of hard work, dedication, discipline, perseverance that mark the individual's journey of our 146 worthy graduates. And these people have completed their degrees. That joy is not just for and with you, but also for your families, friends, and your loved ones who have supported you along the way and who take pride in your accomplishments. And dear guests, I urge you to applaud your special candidates as they walk across the stage, but let's show some restraint and decorum and not go overboard. Because some people do very strange things on the stage. There are 145 more families that would also like to celebrate and hear the names of their children being called. And to our graduates, please follow the formality and instructions as you move across swiftly, as you have been instructed, and remember to have all the stoppages that are necessary for you to stop and receive your accolade. There will be enough time after this after formal proceedings for lengthy allusions, for photographs, and of course dancing. And within the current global climate and local context, many of our students and their families come from difficult circumstances. And of course, these are created by all the problems that we know in the country, but they look forward to a future and a better world for themselves and their families and the country. And for most students, the journey is hard, but you have overcome your difficult circumstances and completed your degree. And you have reached the finish line. The steps you have taken matter and make every hardship, every challenge, every moment of doubt, anxiety you experienced over the past few years worth it. And I wish you a huge congratulations with this remarkable achievement. This week alone, the University of Pretoria will confer 2,106 degrees. And this includes 169 doctorates overall and just about 15,000 graduates for 2025 this year, except the graduation that we'll have in December. And we remain the largest producers of graduates in the country among the contact universities. But your degree is more than a piece of paper. Although that unique quality certificate you are earning today is a firm testimony of the quality of education you have undergone for many years at our beautiful campuses and farms. It is often said that the University of Pretoria is, because we don't talk much, and they say we are a best kept secret. I don't know that, but that's what many people say. You may know that this faculty is the largest and the most diverse of its kind in the African continent. But did you know that up to 25% of the university doctorates that enter the job market in South Africa every year come from this faculty? And through this, we're able to build on the nation's multidisciplinary, interdisciplinary, and transdisciplinary research and teaching capacity. It also means that we make the most meaningful contributions to generating new scientific knowledge, and this knowledge addresses a multitude of complex contemporary challenges in our country and across the globe. And to illustrate the level of experience which I speak of, I'm proud to say that this year, 10 of the 14 University of Pretoria finalists in our 24-25 National Science and Technology Foundation Awards came from the Faculty of Natural Sciences and Natural and Agricultural Sciences. And these are the lecturers of high quality that teach our students. They are behind me here and many others that didn't join this graduation ceremony. They come from the fields such as plant and soil sciences, zoology, entomology, physics, animal sciences, mathematics, and Mammal Research Institute, and many more. And the awards honor and welcome the outstanding contributions of science, engineering, technology, and mathematics, and of course innovation, and giving recognition to professional, innovative research that helps provide solutions to the challenges of the country. Even our students, our postgraduate students, and we have 45 doctoral students in this ceremony, they address critical issues and highlights new information that matters for our ecological importance. One example, of course, is the current research into artifact burrows. And such research is not just interesting, but reconciles food security and conservation. And of course, this is, among others, addressing the United Nations Sustainable Goal 2 and 15, zero hunger and life on land. The many news articles on our websites are peppered with stories of amazing and inspiring achievements. Do yourself a favor if you have not, and check it out, ladies and gentlemen. It is also worth noting that our alumni are globally competitive. They make up to about 14% of highly skilled workforce in Gauteng and 8% in South Africa. At the same time, our global standing in terms of subject rankings, employability ratings, and of course positioning in international research network continue to rise very fast. And 4 of the 5 subjects in which the university is ranked in the top 50 in the world, and of course, in terms of its diversity and scale of international research collaborations, are in this faculty. But apart from the pride in our institutional reputation, which lends gravitas to our degree certificate, the staff of the University of Pretoria also get great satisfaction out of helping our students succeed. And it's important for me to mention this. Some of you graduating today come from poverty and unemployment of your families. And as I said earlier, the journey has been hard. Many of you can attest how people, have been willing at UP to go an extra mile for those facing adversity. That is the UP way. And therefore, it is something that we really appreciate and acknowledge, that each one of the role players here in this complex, holistic educational process, our lecturers, our tutors, our academic support coaches, our lab technicians, librarians, mentors, friends, our sponsors, and our resident psychologists, and all the health practitioners, all our resident house parents, everyone, and parents at home, we truly applaud you for this outstanding performance to guide and support your children and spouses. And on this occasion, I'm just reminded of the words of my all-time favorite rapper, you believe it, I like rap. And that's Calvin Cardoza Brothers Jr. Many of us know him as Snoop Doggy Dogg or Snoop Dogg. Yeah. That's an American rapper and entrepreneur who was born in 1971 in California. Now, he was addressing graduates at the University of Southern California in May 2025. And he said, and I'm going to quote him, and this is American English, so they say university professors don't speak good English. You see, the underdog, that's what he said. You see, the underdog story is the realest story there is. Because when you come from nothing, you appreciate everything. You hustle different, you love different, and you lead different. So today, I want you to do three things. Stay humble, never forget where you came from, stay hungry, keep that fire in your soul, and stay true. Always be real to yourself and the world, because the world don't need no more copies. It needs originals. And trust me, ain't nobody else can do what you do like you do. End of quote. That's Snoop Dogg. And as I conclude, my message to our graduates is, when you walk across the stage today, I trust your learning process with us has been rewarding and transformative. I'm confident that you are well prepared for your careers and equipped, very well-rounded ethical citizens. So that you can hustle, you can love, you can lead with humility, and of course a fiery soul with integrity and truth, with appreciation of all that you have and the hunger for more. May the precious friendships and happy memories of your time here last your lifetime. I urge you to contribute to Choose UP by opting to be a loyal and engaged supporting alumni. I am also confident that you will make lots and lots of spare money. And before you buy wildlife, because when people have money, they buy lions, please share some of it so that the students that come after you can be able to get the support to complete their studies. And keep in touch. We are always here. And huge congratulations again, and thank you. I will now request the Dean to introduce to me the candidates present whose names appear in the program.
Mr. Vice Principal, the Supervisor or Heads of Department will now introduce the doctoral candidates.
Mr. Vice Principal,
Mr. Vice Principal, I introduce to you Rashid Ali Mohammed Adam, who has complied with the requirements for the degree of Doctor of Philosophy in Physics with a thesis titled Design of Human Hair-Derived Activated Carbon, Polyaniline Cobalt Hydroxide Multilayers as a novel electrode for supercapacitors prepared under my supervision. The candidate developed a novel multi-layer electrode for supercapacitor devices using human hair-derived activated carbon, polyaniline, and cobalt hydroxide through a cost-effective and environmentally friendly method. The integration of these materials led to a synergistic multi-layered architecture without understanding electrochemical performance. The resulting supercapacitor devices demonstrated specific energy ranging from 15 to 34 watt-hour per kilogram and a specific power ranging from 750 to 800 watt per kilogram, along with excellent long-term charge-discharge cycle stability. This multi-layer electrode design makes a valuable contribution to developing sustainable energy storage solutions and advances research in clean and effective energy technologies. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, colleagues, it is my pleasure to introduce Laura Jane Bishop, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Immune Response Dynamics and Efficacy of Novel Antigen and Adjuvant Vaccines for Epicephalus microplus, prepared under the supervision of Professor Christine Maritz-Olivier, Dr. Alri Pretorius, and myself. In her thesis, the candidate developed and evaluated next-generation subunit vaccines targeting the Asiatic blue tick Epicephalus microplus, a significant ectoparasite of cattle. The study focused on improving vaccine efficacy through novel combinations of the commercially available antigen BM86 with proprietary antigens and tailored adjuvant formulations. Using a multi-layered approach, including in silico epitope mapping, bovine vaccination trials, immunological profiling, and transcriptomic analysis of the bovine skin at tick attachment sites, the research demonstrated enhanced host humoral and cellular immune responses following vaccination. The findings highlighted critical immune pathways such as toll-like receptor signaling, cytokine receptor interactions, natural killer cell-mediated cytotoxicity, and complement activation that were modulated in response to the optimized vaccine formulations. This thesis significantly advances the understanding of antigen-adjuvant interactions, immune mechanisms of protection, and host pathogen dynamics in the context of tick infestation, offering a roadmap for the development of more effective tick control strategies in cattle. This work has been presented at both national and international conferences and has resulted in the publication of scientifically peer-reviewed publications. Mr. Vice Principal, I request that you confer the degree to the candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Joshua Bota, who has compiled with the requirements of the degree Philosophy Doctor with a thesis titled The Application and Analysis of Single Molecule Spectroscopy Data in Photosynthesis, prepared under the supervision of Professor Jad Kruger. In the thesis, the candidate developed a comprehensive graphic user interface-driven software package for processing and analyzing multi-parameter single molecule spectroscopy measurement. The open source software enabled detailed analysis through tools for statistical evaluation of fluorescence intensity, clustering, level identification, lifetime decay fitting, and second-order correlation calculations. Notably, visualization features, data filtering functionality, and a custom measurement file format differentiate this software as a valuable contribution to the field. The demonstration of the software on photosynthetic light harvesting complex illustrate its use as a powerful platform to bridge the gap between complex experimental data and resulting in insight. In this way, the thesis makes a significant contribution to the field of single molecule biophysics, presenting a tool to further the investigation of light-dependent processes in photosynthesis at the nanometer scale. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Zibusiso Maibonge Buthelezi, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Understanding the Role of Microbial Communities in the Cycling of, this is high English, dimethyl sulfur propionate and related compounds in the Southern Ocean and Atlantic Ocean, prepared under my supervision with Professor Mohase and Dr. Piernov as co-supervisors. In this thesis, the candidate investigated environmental factors that drive sulfur recycling. DMSP and its related climate-active gases may act as feedback mechanisms in climate change. Using multi-omics approaches, the candidate examined microbial contributions to DMSP recycling in the Southern Ocean, sea ice, and also across the Atlantic Ocean. The study provides insights into microbial diversity and its functional role in DMSP production and degradation processes. Overall, the abundance and expression of microbial DMSP degrading genes in the Southern Ocean and Atlantic Ocean indicate the production of several volatile gases which may play key roles in climate regulation and global sulfur recycling. This work advances current insights regarding microbial DMSP recycling. Mayibongwe has traveled the world's oceans, presented across numerous international conferences, and also published his work extensively. Mr. Vice Principal, I request that you confer the candidate the degree.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Ms. Colette de Villiers, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Satellite and Unmanned Aerial Vehicle Technology for Mapping Maize Cropland in the South African Landscape. The candidate developed novel methodologies for advancing in-field crop management, particularly for the vulnerable smallholder farmers in South Africa, by integrating cutting-edge remote sensing technologies with image processing and UAV data. The research represents a crucial advancement in addressing global food security and climate change impacts. The study demonstrates, for instance, that these approaches enable high accurate predictions for maize and land cover classification, effective weed detection, optimal maize yield estimation. This provides vital information for the robust management initiatives, positively contributing to food security of vulnerable smallholder farmers, and validating the transferability of machine learning models for crop monitoring in diverse and resource-constrained agricultural environments, prepared under my supervision with that of Prof. Tess Michael, Dr. Mungamezulu, and Dr. Mashaba Mungamezulu as co-supervisors. Mr. Vice Principal, I request that you confer the degree to the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce you to Loretta Shirley de Bokone, who has complied with the requirements for the degree Philosophy Doctor with a thesis entitled Flow Chemistry Investigations into the Synthesis of Dinipazole, Servoflurane, and Suzuki-Miura cross-couplings, prepared under my supervision with Dr. Jenny Lee Panahides as co-supervisor. In this thesis, the candidate developed innovative flow chemistry methodologies for the synthesis of dinipazole and servoflurane, two critical active pharmaceutical ingredients widely used in Alzheimer's disease treatment and anesthesiology, respectively. By integrating multiple reaction steps into a staggered continuous process, the synthesis of dinipazole showed improved process efficiency, scalability, and safety, particularly in handling hazardous intermediates. The candidate also demonstrated the continuous translation of Suzuki-Miura coupling reaction, a key transformation in carbon-carbon bond formation. This work provides insight into the potential of flow chemistry to bridge the gap between laboratory scale synthesis and industrial pharmaceutical manufacturing by advancing sustainable and green chemistry practices, as well as a practical framework for safer and more efficient pharmaceutical production. Mr. Vice Principal, I request you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Sarah Fife, who has complied with the requirements for the degree Philosopher Doctor with a thesis titled Epidemiological and Molecular Approach to Determine Factors Associated with Diarrhegenic E. coli in Food for Children under 5 in Mozambique, prepared under my supervision and with Dr. Gachure and Dr. Makuamule as co-supervisors. In this thesis, the candidate demonstrates that intrapathogenic E. coli is diarrhegenic E. coli is the diarrhegenic E. coli strain responsible for causing diarrhea in children from both rural and urban areas of Maputo. Through whole genome sequencing, the candidate also demonstrated that food and drinking water are potential sources of DEC, contributing to diarrhea in children under 5 years of age in rural and urban settings. Additionally, the presence of antimicrobial resistance genes was demonstrated in the detected DEC strains. These findings highlight the urgent need to educate caregivers about food preparation, water treatment, and safe storage practices, and to implement effective measures to prevent, control, and monitor the spread of AMR. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Rodrigo Coco Fiavoy, who had complied with the requirements for the degree Philosophy Doctor with a thesis titled Sustainable Management of the South American Tomato Pinworm Pteromia absoluta using biocontrol agents and mesoferrous silica nanoparticles, prepared under my supervision with Professors Baldwin Toto and Fatia Kamisi as co-supervisors. In this thesis, the candidate evaluated sustainable strategies for managing the invasive South American tomato pinworm, which is significantly impacting tomato production in Africa, causing losses up to 100%. He explored integrating the use of predators and parasitoids, as well as silicon-based nanoparticles. His work demonstrated that mesoferrous silica can be a bio-friendly method for protecting tomato through modification of its physical and chemical defenses while enhancing the recruitment of natural enemies and plant defense signaling. Thus, it offers a promising method for reducing chemical pesticide use and improving agroecological practices in the management of tomato pinworm. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Claire Katarina Geldenhuys, who has complied with the requirements for the degree Philosophia Doctor with a thesis titled Advances in Polyaploid Distributions and Applications, prepared under my supervision and with Professor Andriette Becker as co-supervisor. In this thesis, the candidate advances the modeling of overdispersed count data by introducing new bivariate polyaploid distributions and extending them to the multivariate case. These models offer greater flexibility over existing models and address challenges typically encountered in count data, such as overdispersion, zero inflation, and 0 and 1 inflation. Simulation studies and applications to benchmark data sets demonstrate the enhanced performance of these new models compared to existing alternatives. In addition to proposing the new distributions, the thesis refines the probability mass functions and distributional properties of existing polyaploid models, improving their practical relevance. Overall, the thesis contributes significantly to statistical methodology by extending the theoretical foundation and practical use of the polyaploid distributions, offering new pathways for future research in applied count data analysis. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce you to Caitlin Gevers, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Changes in Genetic Diversity of Leptocybe invasive Populations in South Africa and its Impact on Pest Management, prepared under my supervision and with Professor Bernard Slippers and Dr. Gudrun Dietrich-Schroeder as co-supervisors. In this thesis, the candidate investigated the genetic diversity of the invasive gall wasp Leptocybe invasa in South Africa and its implications for management. The study revealed the coexistence and admixture of two distinct wasp lineages in South Africa through the integration of molecular tools, national field monitoring, and host preference testing. It also documented the spread of effective parasitoids, both intentionally and accidentally introduced. The research provided critical insights into how subspecies level genetic variation influences host selection and interactions with natural enemies. These findings offer scientific foundation to inform integrated pest management approaches, including host resistance breeding, targeted use of biological control agents, and long-term monitoring strategies for sustainable forestry. Mr. Vice Chancellor, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Chancellor, I introduce you to Sanfir Hariprasad, who has complied with the requirements for the degree Philosophy Doctor with a thesis entitled Examining Non-Parallel Interest Rate Risk Premia with a focus on South African markets, prepared under my supervision. In this thesis, the candidate examined sovereign yield curves in emerging and developed markets, finding that non-parallel shifts are more common in emerging markets due to higher political and economic risks. Key drivers include war, debt distress, and pandemics, with geopolitical risks increasing over time. The study identified South Africa's swap and bond markets as well suited for exploiting non-parallel risk premia due to its opposing monetary and fiscal policies. A long butterfly strategy with a cash and duration neutral weighting approach was found to be the most effective. Backtesting of butterfly risk factors showed persistence outperformance, especially during steep twists and curve flattening scenarios, challenging the strong, efficient market hypothesis. The all-factor rank further improved diversification. Trade costs were a key consideration, with quarterly rebalancing frequencies reducing costs and enhancing net returns. These findings demonstrate butterfly risk factors as a viable portable alpha strategy in South African fixed income markets. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges in the country.
Mr. Vice Principal, I introduce to you Matthew Andrew Harris, who has complied with the requirements for the degree Philosophy Doctor, with a thesis titled Spatial Patterns of C4 Grass-Associated Fungal Endophyte Communities, supervised by Professor Michelle Grewe, Dr. Martin Kemmler from the University of Hamburg, and myself. In this thesis, the candidate explored which factors drive diversity and composition of foliar fungal endophyte communities of important African grass species. By integrating sophisticated ecological modeling techniques, the body of work presented in this thesis represents a significant advance in our understanding of the effect of environmental drivers and plant traits on endophyte diversity and composition patterns at local and global scales. The candidate demonstrates, for instance, that foliar fungal endophytes follow a classical latitudinal diversity gradient for species richness. This pattern is commonly observed for macroorganisms, but rarely for microorganisms. Additionally, trait trade-offs in grass species are reflected in endophyte community composition, suggesting a link between endophyte communities and grass functioning. The approaches used in this thesis highlight that using complex statistical models developed for macroorganisms can yield valuable insights into highly complex microbial communities. Mr. Vice Principal, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges of the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Daryl Arthur Heron, who has compiled with the requirements for the degree Philosophy Doctor with a thesis titled Fusarium Diversity Associated with Poesy in the Pinus Nursery and Plantation Environment, prepared under the supervision of Professor Emma Steenkamp and with Professor Brenda Wingfield, Professor Mike Wingfield, and myself as co-supervisors. In this thesis, Fusarium diversity associated with poesy in the Pinus nursery and plantation environment, the candidate's research focused on Fusarium circinatum. This globally significant fungus threatens pine trees in commercial forests, nurseries, and plantations. His work revealed that grasses, often overlooked in these environments, can asymptomatically harbor this pathogen and act as hidden inoculum sources. This research highlights significant biosecurity risks by identifying numerous grass species that can host Fusarium circinatum, including many new associations, and documenting wide genetic and disease-causing variation among fungal strains. The candidate also discovered 15 previously unknown Fusarium species in forestry environments. This finding underscored the need for careful grass management and improved pathogen surveillance to protect forest health. This work offers insights for biosecurity, helping to future-proof plantation against disease and improve global efforts to manage plant pathogens in commercial forestry system. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce you Melissa Hubert, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Investigating the Molecular Mechanisms Underlying Avocado Sunblotch Disease, prepared under my supervision, and with Professors Jacques Tron and Ilani van der Berg as co-supervisors. In this thesis, the candidate examined the molecular changes associated with avocado sunblotch viroid infection in both asymptomatic and symptomatic trees. By leveraging next-generation sequencing technologies, the research explored how asymptomatic infections impact the host transcriptome and revealed how viroid-derived small RNAs mediate avocado sunblotch disease development. The work demonstrated that viroid infection disrupts the expression of numerous avocado genes involved in key cellular pathways, even without visible symptoms. Furthermore, the study confirms the critical mutation within the viroid genome linked to chlorotic symptoms. It demonstrates how viroid-derived small RNAs target and silence chloroplast-related genes to initiate leaf bleaching. This thesis highlights the benefits of integrated high-throughput sequencing analysis for studying viroid-host interactions. It offers novel insights into the disease caused by avocado sunblotch viroid and other members of the family Apsynviridae. Mr. Vice Principal, I request you to confer the degree on the candidates.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Rua Kakali, who has complied with all the requirements for the degree Philosophia Doctor with a thesis titled Unraveling Tissue-Level Symbiont Pathogen Interactions in Exoded Ticks of Dromedary Camels in Kenya, Insights into Vector Competence, prepared under my supervision and with Dr. Yandawa Villinger and Dr. Daniel Masiga as co-supervisors. In this thesis, the candidate developed a novel protocol for isolating multiple tissues from a single tick, enabling the first molecular comparison of tick-borne pathogen and microbiome interactions within specific tick tissues. Key findings include that tissue type strongly shapes microbiome composition with clear indications of niche partitioning and microbial interactions that affect pathogen viability and transmission. Notable outcomes include the identification of tissue-specific keystone taxa, negative interactions between pathogens and endosymbionts, and the potential use of hemolymph as a marker for vector competence and TBP diagnostics. Overall, this research provides critical insights to guide the development of targeted tick control strategies, including antimicrobiota vaccines, and advances understanding of tick pathogen dynamics and disease ecology in camel populations. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Sinotile Samantha Kuzwayo, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled The Anti-HIV and Anti-Cancer Capabilities of Novel 3-Benzyl Benzofurans and their pyrazole derivatives, prepared under my supervision with Dr. Mamulosi Silepe and Professor Deborah Mayer as co-supervisors. In her thesis, the candidate synthesized, derivatized, and characterized novel compounds, followed by biological screening for anti-HIV and anti-cancer activities. Derivatization of benzofurans into pyrazoles was demonstrated to significantly decrease cytotoxicity, making pyrazoles more suitable as potential antiretrovirals. Mechanistic studies were conducted, and it was revealed that the active pyrazole compounds inhibit HIV replication by blocking HIV N3 through CCR5. Additionally, these novel compounds exhibited moderate inhibition of HIV protease, which is important for the maturation of the virus into infectious virus particles. Moreover, the benzofuran compounds showed dual activities against cervical cancer cells and HIV, with high selectivity and low toxicity to normal human cells, addressing the limitation of current antiretrovirals in terms of side effects. This research has been published in the journal RSC Medicinal Chemistry and presented at various national and international conferences, contributing valuable insights to the development of novel therapies for HIV and cancer treatment. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Shartilal Desapat, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Stakeholder Perspectives on Governance Challenges for Addresses in South Africa and Transformative Ways Forward, prepared under the co-supervision of Professor Serena Kutsia and I. In this thesis, the candidate investigated stakeholder perspectives on the governance challenges surrounding ADRES infrastructure in South Africa. Using governance as a conceptual entry point and insights from semi-structured interviews, the candidate analyzed how various public sector stakeholders, those who depend on ADRES data to carry out their mandates, navigate a fragmented and constrained institutional environment. The study highlights the persistence of ADRES-related issues as a long-standing public concern requiring inclusive, coordinated governance practices. It further shows that stakeholders' current adaptive strategies are insufficient and contributes to a continued strategic drift. The thesis identifies this moment as a critical juncture that demands deliberative decisions and institutional commitments to enable a strategic shift in addressing governance. The candidate proposes insightful transformative recommendations to guide stakeholders towards long-term coordinated solutions for improving addressing infrastructure and governance in South Africa. Mr. Vice Principal, I request you to confer the degree on the candidate.
Hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Chancellor, I introduce to you Tseposo Mabelana, who has compiled the requirement for a degree philosopher doctor with a thesis titled Effect of 710 MeV bismuth ion irradiation and annealing on selenium implanted silicon carbide, prepared under my supervision and with Dr. Zaki Abdallah as the co-supervisor. In this study, Mr. Mabelana investigated the effect of swift heavy ions and annealing on selenium pre-implanted silicon carbide using the state-of-the-art equipment such as TEM, SEM, Raman spectroscopy, and RPS. The result revealed that implantation at room temperature amorphized the silicon carbide structure, while implantation at elevated temperature preserved the crystallinity of silicon carbide with some defect. Swift heavy ion irradiation at room temperature caused limited recrystallization, while annealing at high temperature enhanced recrystallization of silicon carbide. No significant migration of implanted selenium was observed after swift heavy ions and annealing up to temperature exceeding that of operation temperature of nuclear reactors. This research offers key insight into silicon carbide radiation tolerance and migration of fission products such as selenium, supporting the development of safer, more efficient nuclear fuel for the next nuclear generation. The results of this study have been published in peer-reviewed journals and also presented in both national and international conferences. Mr. Vice Chancellor, I request you to confer the degree to Mr. Mabelana.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Chancellor, I introduce to you Zoology, Robert Maisha, who has complied with the requirements for the degree Philosopher Doctor with a thesis titled Modeling of eThekwini Heat Islands under Climate Change, prepared under my supervision and with Dr. Mary Jane Bupape and Professor Engelberg. In his thesis, the candidate developed a novel tool for understanding urban climate. The candidate further downscaled the conformal cubic atmospheric model to a high resolution of 1 kilometer and coupled it with an urban climate model that incorporated measured urban parameters and actual land cover. The work represents a significant advancement in understanding the impacts of recent increases in nighttime minimum temperatures and surface temperatures on the development of urban heat islands, both under current climate conditions and those anticipated in the coming decades. The candidate demonstrates, for instance, that the climate models, when parameterized with measured data, can produce high accurate projections of the urban heat island. The approaches developed in this thesis provide essential information for mitigating the impacts of the urban heat island and adaptation thereto in an increasingly warming climate. Mr. Vice Chancellor, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you John Paul Makumbi, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled An Ecological Approach to Risk Characterization of Antimicrobial Resistance from South African Urban Wastewater and Freshwater Microbiomes, prepared under my supervision with Dr. Chem Eng as co-supervisor. So antimicrobial resistance is regarded to be the next pandemic. In his thesis, the candidate investigated the factors influencing the persistence and transmission of antimicrobial resistance genes, ARGs, and antimicrobial resistance bacteria, ARBs, in South African aquatic systems. Using a microbiome and ecotoxicology approach, the study showed that wastewater treatment plant efficiency, environmental compartmentalization, and several factors, including temperature, pH, salinity, nutrient concentration, and heavy metal contaminants, significantly influence ARG and ARB dynamics. The data underscore the potential of these markers as proxies for antimicrobial resistance surveillance. Notably, the study provides the first evidence from African wastewater treatments, plants, and freshwater systems, highlighting the crucial role of extracellular DNA in shaping aquatic resistomes through facilitating AMR persistence and transmission. These findings provide essential insights for improving sanitation and environmental protection practices to curb AMR spread and reduce public health risk. Mr. Vice Principal, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Hezekiah Mapingere, who has compiled with the requirements for the degree Philosophy Doctor with a thesis titled Computational Insights into Charged Dopant Vacancy Device Complexes in Graphene for Nanotechnology Applications, prepared under the supervision of Dr. Refilwe Mapash. In the thesis, the candidate utilized first principles methods to study nitrogen vacancy point defects in the two-dimensional material graphene. The study was centered on understanding the impact of nitrogen vacancy point defects in modifying the properties of graphene. The candidate used density functional theory, DFT, to comprehensively study the local properties of graphene once a point defect complex was introduced into the material. The candidate carried out ab initio calculations on point defects in graphene and developed a significant comparative characterization of nitrogen vacancy point defects in it. This thesis will assist material scientists in comprehending how NV-like point defects alter the electron properties of graphene at nano level. This contribution can open up new ground for defect-modified graphene, a very important material for fabricating nano devices of various applications. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Tlaleo Morole, who has complied with the requirements for the degree Philosopher Doctor with a thesis titled Viability and Functionality of Lacticacea-Bacillus rhamnosus and Bifidobacterium species in yogurt, prepared under my supervision and with Dr. Sibanda as co-supervisor. In this thesis, the candidate developed a novel qPCR method using tough gene-based primers combined with Probodium monoxide to solve the challenge of quantifying probiotic viability during yogurt shelf life. The PMAX qPCR approach proved more reliable and selective, especially for distinguishing among closely related lactic acid bacteria and probiotic species such as L. rhamnosus and Bifidobacterium and yogurt starter cultures. Furthermore, the candidate demonstrated that co-cultures of L. rhamnosus and Bifidobacterium species in yogurt improve production of bioactive metabolites such as short-chain fatty acids and peptides, and for the first time reported their exopolysaccharide production in yogurt. These findings offer valuable insights to the dairy and probiotic industries for developing functional yogurts with improved probiotic viability and health-related functionality. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Simpiwe Maseko, who has complied with the requirements for the degree Philosopher Doctor with a thesis titled Evaluating Machine Learning and Process-Based Crop Modeling Approaches for Spatial Maize Yield Predictions in Precision Agriculture, under my supervision and with Professor Eop Tesfamariam as co-supervisor. In this thesis, the candidate explored the potential of artificial intelligence in agriculture by applying machine learning techniques and a process-based model for spatial grain yield predictions. The study is the first in South Africa to innovatively integrate machine learning techniques with process-based models for improved decision-making on optimum input applications in precision agriculture. The body of work presented in this thesis contributes meaningfully to academic knowledge and practical implications in cropping systems to guide the development of decision support platforms for informed decision-making. This study is expected to have lasting impact on the development of decision support platforms and the application of artificial techniques in precision agriculture. Mr. Vice Principal, I request you confer the degree on the candidate.
I hereby confer the degree of philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Hele Tesfaye Mehari, who has complied with the requirements for the degree Doctor of Philosophy with a thesis titled The Effects of the Land Certification Program on Land Tenure Security and Soil Conservation Investments in Rural and Peri-Urban Areas of Northern Ethiopia, prepared under my supervision. In this thesis, the candidate employed econometric tools to analyze the effects of the land certification program on land tenure security and soil conservation investments. The body of work in the thesis enhances our understanding of how land certification programs affect land tenure security and soil conservation practices by disaggregating farmers into peri-urban and rural categories. This approach incorporated geographic location into the analysis, addressing limitations of previous studies that produced incomplete results. This research significantly advances the understanding of the differential effects of land certification, revealing that these effects vary considerably based on the geographic location of farm households. The candidate demonstrates a positive effect of the land certification program among rural farmers, while peri-urban farmers encounter unique challenges that require targeted solutions. The approach developed in this thesis provides essential insights for location-specific program evaluations, particularly relevant in the context of rapid urbanization. Mr. Vice Principal, I request you to confer the degree on the candidate.
Hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice President, Principal, I introduce to you Fanele Mngini, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Taxonomy and Comparative Genomics of Bacterial Species Associated with Onion Bulb Rot, focusing on Rhinella species, prepared under my supervision and with Dr. Gina Shin as co-supervisor. In this thesis, the candidate focused on the bacterial pathogens that threaten onion production, with a particular emphasis on emerging opportunistic species. This study identified the key bacterial species responsible for onion bulb rot by analyzing diseased onion bulbs from South Africa. A significant development was characterizing a novel Erengella species and identifying known Rhinella species from South Africa and the United States. Comparative genomic analyses of these Rhinella species revealed pathogenicity-related genes, including those associated with metabolic functions, secretion systems, and the biosynthesis of antimicrobial compounds. This study highlights the complexity of onion bacterial bulb rot and emphasizes the importance of surveillance and the need to develop sustainable disease management strategies for these opportunistic pathogens to protect onion production and ensure food security. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Ms. Titiro Judith Moloto, who has complied with the requirements for the degree of philosophy degree with a thesis entitled Intrinsic and Extrinsic Factors Associated with the Decline of South African Lark Species. Alluded to. This was prepared under the supervision of Prof. Paulette Bloomer and with me as a co-supervisor. In this thesis, the candidate developed tools for understanding how climate change and habitat changes affect the abundance and distribution of larks. The research provides insight into the role of life history traits in limiting or promoting adaptation to changing environments. The candidate developed new tools for obtaining genomic DNA from feathers and towpaths from museum specimens. The candidate integrated citizen science, weather, physiology, behavioral, and life history traits, and genetic data with cutting-edge analysis to improve understanding of the decrease and increase of lark populations. This work demonstrates that the currently observed population trends of South African lark species varied between species and can be explained by complex relationships between and among environmental pressures, life history traits, and genetic diversity. The findings contribute to conservation planning in our rapidly changing environment. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Tisetso Mosala, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Using the Perceptions of Lecturers and Students to Design a Spiral Curriculum for a Chemistry Module in the Academic Development Program. The thesis was prepared under my supervision with Dr. Khadima Tabate as a co-supervisor. In this thesis, the candidate investigated the application of students and lecturers' perceptions to inform the redesign of a first-year chemical engineering chemistry course curriculum within the context of the 5-year engineering degree. The findings of the qualitative study indicate the necessity of horizontal curriculum alignment, ensuring coherence between courses taught at the same academic level so that each course logically builds upon the preceding one. Additionally, the study underscores the significance of harnessing the student voice to evaluate and enhance the curriculum. Furthermore, the study presents a transferable model for designing a spiral curriculum in any educational context. This model integrates disciplinary perspectives with the lived experiences of the students and lecturers. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Mariam Nakitu, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Sensory-Based Methodologies for Facilitating Demand-Led Sweet Potato Breeding, prepared under my supervision. The candidate developed a lexicon comprising 27 attributes and protocols for descriptive sensory analysis of sweet potato. This enabled the characterization and differentiation of genotypes using sensory profiles and instrumental texture assessments. She developed a gender-responsive, consumer-based decision tree for calculating an eating quality selection index when screening lines in demand-led targeted sweet potato breeding. She identified 105 volatile compounds that contribute to the enhancement or suppression of aroma and flavor perception of sweet potato, of which 40 compounds contribute majorly. The research yielded 4 complementary tools for use in sweet potato breeding programs to rapidly and effectively select genotypes with consideration of the sensory preferences of consumers. Integrating these tools at various stages across the breeding cycle could contribute to increased adoption of outputs from sweet potato breeding programs. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Mr. Simpiwe Lindakule Nlangamandla, who has compiled with the requirements for the degree Philosophy Doctor with a thesis entitled Macromolecular Copper-Based Complex Catalyzed Electrochemical Carbon Dioxide Reduction using an Electrolyzer Cell, prepared under my supervision. In this thesis, the candidate worked on the most important topic of today, mitigating carbon footprint via conversion of CO2 to useful fuels. In this work, the candidate performed electrochemical reduction of CO2 on a copper porphyrin electrocatalyst via 2 routes: a zero-gap polymer electrolyte membrane electrolyzer setup, a 3-electrode flow assembly with anion exchange membrane and a proton exchange membrane. For the first time, a zero-gap polymer electrolyte membrane electrolyzer setup was used to successfully perform electrochemical carbon dioxide reduction in a basic electrolyte medium, which produced carbon monoxide, methane, and ethylene, indicating that a simple setup can be easily modified to produce a scalable system. On the other hand, experiments performed using the same electrocatalyst in a more sophisticated 3-compartment MEA electrolyzer produced carbon monoxide, formic acid, methane, ethylene at a combined Faraday efficiency of 16.5%. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Mr. Lwandile Nduku, who has complied with the requirements of the degree Philosophy Doctor with a thesis titled Assessing the Potential Use of Unmanned Aerial Vehicle Remote Sensing Data for Advancing Field Scale Wheat Monitoring Approaches, prepared under my supervision and with Kalumba, and Doctors Mgemezulu, Doctors Mashaba, and Dr. Masiza as co-supervisors. In this thesis, the candidate developed a novel methodological approach for improving the accuracy of monitoring biophysical parameters and yield estimation in wheat crops using cutting-edge technologies such as unmanned aerial vehicles by integrating multi-scale remote sensing platforms, including high-resolution data sets from Sentinel-1 and Sentinel-2 with advanced machine learning techniques. The research presents innovative data analytics to support precision agriculture. The finding demonstrates how data fusion and scalable remote sensing technologies can significantly enhance wheat growth monitoring, enabling better identification of field-level variability. This in turn allows for more precise nutrient application, targeted irrigation, and real-time crop management strategies to increase yield and food security. The thesis highlights the critical role of UAVs and remote sensing in transforming cereal production. Mr. Vice Principal, I request you to confer the degree on the candidate.
Hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Arnoldus Otto, who has complied with the requirements for the degree Doctor of Philosophy with a thesis titled Advancements in Contaminated Models from Count to Continuous Data, prepared under my supervision and with Professor Andriette Becker and Professor Antonio Punzo as co-supervisors. In this thesis, the candidate contributes to a flexible statistical framework for handling atypical values in real-world data using contaminated models, two-component finite mixtures both situated at the same location, but where one component captures typical data and the other, with increased dispersion, models atypical values. This structure yields interpretable, heavy-tailed distributions that can be effectively applied across various statistical domains. The thesis first develops univariate contaminated negative binomial and beta binomial regression models for count data. The second part proposes multivariate models for continuous data, particularly the mode parameterized inverted Dirichlet and shifted asymmetric Laplace cluster-weighted models. The methodology was validated through extensive simulation studies and applications to real data sets, demonstrating improved estimation accuracy in the presence of atypical values and the detection thereof. Our packages were developed to promote reproducibility and allowing practitioners to implement the proposed models seamlessly. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Teke Solomon Ramatubei, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Numerical Experimentation on the Mechanisms and Processes of the Intertropical Convergence Zone Meridional Shift Seasonal Context, prepared under the supervision of Dr. Asmarom Baraki and with Professor Landman and Dr. N.J. Mateyesi as co-supervisors. In this thesis, the candidate applied multiple procedures to identify the Global Intertropical Convergence Zone, ITCZ, under different El Niño Southern Oscillation ENSO phases. Furthermore, he investigated the performance of the seasonal forecasting system from the CSIR in predicting the ITCZ position by applying advanced process-based model evaluation techniques. The thesis significantly contributes to understanding and modeling the regional ITCZ during different ENSO phases. The CSIR seasonal forecasting system was reliable in predicting the ITCZ position during the summer seasons. These results provide the baseline for applying the Earth system models and simulating the ITCZ and studying its future response to a changing climate. Results also provide an opportunity to study the teleconnections between ITCZ and regional rain-bearing systems to improve sub-seasonal to seasonal forecasting. Mr. Vice Principal, I request you to confer the degree on the excellent candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Mary Ronchetti, who has complied with the requirements for the degree Philosophia Doctor with the thesis titled Genome Sequences and Molecular Resources for Macadamia Tree Breeding in South Africa, prepared under the supervision of Prof. Zander Mayberg and with Prof. Gerda Fourie, Dr. Charles Jeffer, and myself as co-supervisors. In the thesis, the candidate developed novel tools for molecular-based breeding of macadamia. Using advanced DNA technologies, the work presented in the thesis provides important resources to improve macadamia nut production. First, the unique population dynamics of macadamia cultivars grown in South Africa were assessed in the context of international cultivars. Second, whole genome sequencing and assembly were performed for 3 cultivars. Third, the underlying genetic mechanisms associated with the unique oil content of macadamia nuts were assessed. Furthermore, the candidate developed a DNA marker panel for routine DNA analysis, which is being provided as a service to the macadamia industry through the Precision Tree Breeding Platform at the University of Pretoria. The resources generated in this thesis provide the first step in developing advanced molecular tools for accelerated breeding programs for macadamia nut production. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Marco Dura Sanka, who has complied with the requirements for the degree Philosophy Doctor with a thesis entitled Participation, Utilization, and Productivity Welfare Impacts of Agricultural Credit Guarantee Schemes among smallholder rice farmers in Tanzania, prepared under my supervision. In this thesis, the candidate examined participation, credit utilization, and the impact of the agricultural credit guarantee scheme among smallholder rice farmers in Tanzania. By employing robust econometric techniques, the empirical work presented in this thesis represents a significant advance in our understanding of the factors influencing smallholder farmers' participation in the agricultural credit support programs, credit utilization levels, and the impacts on the rice productivity and household welfare. The candidate indicates that socioeconomic, farm-related, and institutional characteristics are key drivers of participation in the credit guarantee scheme and credit utilization levels. Moreover, the candidate demonstrates that participation in the credit guarantee scheme significantly impacts rice productivity and household welfare in Tanzania. The evidence from this thesis underscores the fact that the agricultural credit guarantee scheme is a crucial policy instrument in enhancing access to agricultural credit, improving smallholder farmers' productivity, and promoting household welfare in Tanzania. Mr. Vice Principal, I request you to confer the degree to the candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Christian Skitter, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Enhancing Stream Flow Prediction by Leveraging Deep Learning and a Process-Based Hydrological Model for 2 headwater catchments of the Stilpoort River, prepared under my supervision and with Dr. Barend van der Merwe as co-supervisor. In this thesis, the candidate developed novel deep learning tools to address the challenges of stream flow prediction in regions with declining rainfall and limited monitoring data. By implementing unique modifications to gated recurrent unit and long short-term memory architectures, the candidate demonstrated the potential of deep learning for stream flow prediction in South Africa. The models achieved reliable predictions using actual weather station data and moderate accuracy with freely available gridded data, outperforming the process-based soil water assessment tool plus model. A hybrid approach integrating synthetic high-flow data generated by the SWOT plus model with deep learning was used to address the issue of inaccurate high-flow data. The approaches developed in this thesis represent a considerable advance in stream flow prediction, addressing critical data gaps and supporting sustainable water resource management in South Africa. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Bonwell Simani, who has complied with the requirements for the degree Philosophia Doctor with the thesis titled Assessing the Impact of Invasive Parachana Species on Oreochromis microchir and Other Fish Species of the Mweru Luapula Fishery, prepared under my supervision, and with Professor Paulette Bloemer, Mr. Ari Klopper, and Professor Cyprian Katango as co-supervisors. In his thesis, the candidate developed novel tools by combining traditional or conventional methods alongside structured questionnaires, DNA barcoding, and environmental DNA to assess the impact of invasive Parachana species on Oreochromis microchip and other fish species of the Veru Luapula fishery. By integrating the approaches, the body of work presented in the thesis represents a significant advancement in understanding the status of the fishery, confirming the presence of invasive Parachana obscura, as well as rare and cryptic species, and revealing changes in species composition and diversity of the fishery. The candidate demonstrates that an integrated approach can efficiently monitor the presence of alien invasive species and effectively assist in managing and conserving the threatened aquatic biodiversity of the Zambian freshwater fishery. The study contributes to building a database of Zambian fish fauna by providing DNA barcode reference sequences. Mr. Vice Principal, I request you to confirm the degree on the candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Garen Townsend, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Ecology, Impact and Potential Parasitoids of the Polyphagous Shuttle Borer Eualacia fornicatus in South African forests, prepared under my supervision and with Professor Francois Rutz and Professor Martin Hill as co-supervisors. In this thesis, the candidate conducted the first comprehensive ecological assessment of this invasive skeletine beetle in native forest ecosystems. The research showed rising infestation trends, with forest composition playing a key role in vulnerability. Tree species richness mitigated attack severity, while host-dense areas experienced greater damage. Ethanol-baited trap surveys uncovered unexpected skeletine diversity, and the presence of the polyphagous shuttle borer appeared to facilitate shifts in beetle communities. Parasitoid emergence studies revealed several native wasp species, potentially expanding their host range to include the invasive beetle, offering preliminary hope for natural regulation. Collectively, the findings provide a critical foundation for understanding the ecological role of this invasive beetle and informing sustainable management and monitoring strategies. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce to you Mandeli van der Walt, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Novel Analogues of the Scorpion Venom-Derived Peptide, Opastoporin 1, Targeting Gram-Negative Bacteria, prepared under my supervision and with Professor Megan Bester as co-supervisor. In this thesis, the candidate addressed antimicrobial resistance, focusing on resistant gram-negative pathogens, emphasizing the urgent need for new therapeutics. The research highlights antimicrobial peptides for their broad-spectrum efficacy, rapid action,
and lower likelihood of inducing resistance. The study screened 46 peptides from indigenous African species for activity, toxicity, and structural properties. Scorpion venom-derived peptides exhibited the highest antimicrobial activity, but also significant toxicity. Multivariate analyses revealed that the negative lipophilicity of polar residues is crucial for peptide selectivity. Using in silico, in vitro, and in vivo methodologies, the study investigated the novel scorpion venom peptide Opus 16A and explored modification strategies to enhance its efficacy. Overall, this work demonstrates effective strategies for improving antimicrobial peptide selectivity and activity, highlighting their potential as viable treatments for gram-negative infections, particularly in wound care. Mr. Vice Principal, I request you to confer the degree on the candidates.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, I introduce you to Andries van die Kerk, who has complied with the requirements of the degree Philosophy Doctor, with a thesis titled An Analytical Examination of Retirement Strategies in South Africa, prepared under my supervision. In this thesis, the candidate investigated the sustainability of retirement strategies within the South African context, focusing on balancing longevity, mortality, and financial risks. The study evaluated hybrid strategies that integrate annuities and diversified investment portfolios to address challenges like healthcare costs, inflation, and currency fluctuations. South Africa retirees often face a 6.7 average annual withdrawal rate, exceeding the recommended international 4 to 5%, which risks early portfolio depletion. The study examined the effectiveness of incorporating foreign exposure gains explicitly with stochastic modeling of exchange rates and inflation in both the United States and South Africa. Advanced techniques, including the hyperbolic tangent Ornstein-Uhlenbeck process, simulated realistic asset behavior and stochastic correlation across market conditions. The research provides insights into optimizing living annuities and retirement portfolios, which enhances sustainability and success rates in response to real-world financial uncertainties. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Okay. Mr. Vice President, I introduce to you Yazid van Wyk, who has complied with the requirements for the degree Philosophia Doctor with a thesis titled Combined Use of Environmental and Artificial Traces to Characterize the Anthropogenically Altered Vado Zone, prepared under my supervision and with the external co-supervision of Prof. Kai Vetuza and Dr. Yunus Ubomba Jazwa. In his thesis, the candidate, Yazid van Wyk, investigated the impact of open-pit mining on groundwater flow and contaminant transport in altered subsurface environments. Integrating environmental and artificial traces with analytical modeling reveals how mining activities, particularly blasting, significantly alter fracture connectivity, reshaping contaminant pathways and increasing transport mechanism complexities. Key contributions include quantifying seasonal flow and contaminant transport changes and developing a conceptual site model highlighting the immediate and long-term impacts of mining-induced alterations on groundwater systems. These findings offer a valuable framework for post-closure monitoring and adaptive management strategies in fractured vader zones. The study bridges traditional tracer applications and mining hydrology, establishing a new methodological standard for characterizing contaminant transport. These findings provide a scientific basis for sustainable groundwater management and pollution control in mining-impacted regions, offering valuable guidance for addressing anthropogenic impacts in comparable settings. Mr. Vice President, I request you to offer the degree on the candidate.
I hereby confer the degree, Doctor of Philosophy, with all its associated rights and privileges on the candidate.
Mr. Vice Principal, I introduce to you Kyle Venter, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Factors Affecting Calcium and Phosphorus Digestibility in Broilers with Subsequent Impact on Performance and Bone Mineralization, prepared under my supervision and with Dr. Peter Plumstead as co-supervisor. In this thesis, the candidate explored the novel concept of digestible calcium and its application in poultry nutrition, addressing key factors influencing calcium digestibility and its effect on broiler performance, skeletal mineralization, and feed efficiency. The work demonstrates that adopting a digestible calcium system enhances precision in the diet formulation, reduces nutrient excretion, and supports sustainability in poultry production. This research provides novel insights into the interaction of calcium with dietary components and the implications of ingredient and additive selection on calcium bioavailability. The candidate's findings offer practical and economical viable strategies for improving mineral utilization in modern broiler production systems. Mr. Vice Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Good afternoon. Mr. Vice Principal, I introduce to you Nosipo Tombani Swane, who has complied with the requirements for the degree Philosophy Doctor with a thesis titled Climate Change Impacts on the Nexus Between Water, Energy, Food Resources, the Cases of Narok County in Kenya, and the Fembe District Municipality in South Africa. Prepared under my supervision and supported by the co-supervision from Professor Tavaswane Mabaudi, previously at the University of KZN, but currently at the London School of Hygiene and Tropical Medicine. In this thesis, the candidate
undertook a comparative study of 2 different sites in Africa that exhibited similar socioeconomic, environmental, and technological circumstances. The formulated research constructs demonstrate that both study sites have statistically significant interlinkages between the water, energy, and food nexus, commonly known as the wave nexus, resources which have apparent insecurities under the changing climate. The novelty of this work is based on the parsimonious use of an often complex wave nexus framework modeling framework, but we simplified it insofar as the study outputs are concerned. But for the first time, the candidate was able to infuse the community's perspective of climate change impacts into the modest modeling framework that is based on, for the first time again, structural equation modeling. So she's the only one, and she has published a lot on that. Structural equation modeling framework. So I'm very proud of that. So the study demonstrates that transformative, gender-inclusive, socio-economic development options across Africa should be adopted to ensure that communities are sustainable and resilient in the current climate change issues. Mr. Vice President, I request you to confer the degree to the candidate. Thank you.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate. Congratulations.
Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Science, specializing in actuarial science. Johanna van Heerden with distinction. Specializing in advanced data analytics, Lebogang Baloy. Abigail Mberi with distinction. Specializing in biochemistry, Marta Muruya. Nomthandazwa Ndlangamandla. Specializing in biotechnology, Nombulelo Mbamba with distinction. Robin Skipper. Sheldon Vivier. Specializing in engineering geology, Leandi Brains. Specializing in entomology, Frederik Henneke. Specializing in environmental management, Amogelang Boysen. Akila Karim. Busi Sebutoma. Specializing in food science, Ursula Kana. Specializing in forest science, Wanga Nemavola. Sandra Shishonga. Specializing in genetics, Tegan Fuchs, with distinction. Elisabeth Kruger. Anya Piso, with distinction. Specializing in geoinformatics, Luco Gozo. Specializing in geology, Glenens Ngumani. Specializing in hydrogeology, Marjuan Fasahi. Specializing in medicinal plant science, Willem Boshoff, with distinction. Specializing in meteorology, Donald Nkabinde, with distinction. Specializing in microbiology, Michelle Becker, with distinction. Tembeka Mkize. Vangani Mulaudzi, with distinction. Specializing in nutrition, Gabriela Lorenko. Specializing in physics, Sibongu Musa Shungube. Keegan van den Heuvel, with distinction. Specializing in plant pathology, Angelique de Wet. Specializing in plant science, Yulani Bezuidenhout. Bongakile Kuhlase. Specializing in water resource management, Prudence Madonsela. Specializing in zoology, Megan Hudson, with distinction. Richelle Moelman. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Science in Agriculture in Agricultural Economics. Masego Muabi. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Science in Agriculture in Agronomy. Walter Mokgobu. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Science in Agriculture in Animal Science in Animal Nutrition. Kyle Kutsia. Jonathan Duvall. Johannes Dreyer. Jamie Fourie, with distinction. Maria Herselman. Clarice van den Berg. Johan Verwey, with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Master of Science in Agriculture in Plant Pathology. Sinetemba Nkosi, with distinction. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Actuarial Science. Nina Mare. In Engineering and Environmental Geology, Ronan Perring. In Financial Engineering, Siyabonga Mtombeni. Siphelele Vilakati. In mathematical statistics, Lindy Brits. Onalena Mafatlane. Kedibone Mashalwani. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Consumer Science in Food Retail Management. Sipongiseni Ponkaela. Specializing in Clothing Retail Management, Brenna Tooley. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science in Biochemistry. Calvin Jean-Jacques. In Biotechnology, Bronwyn Easdale. Jordan Roux. In Environmental and Engineering Geology, Veronica van Vuren. In Genetics, Keenan Chetty. François van der Merwe. In Human Genetics, Safiwe Lubuzo. In Human Physiology, Charity and Chabeleng. In Human Physiology, Genetics and Psychology, Constance Mukwevo. Muofe Musenwa. Nandipa Ngonyama. Candice Phillips. In Mathematical Statistics, Bradley Griffin. Priyana Maharaj. Mahaseng Mukhata. Busiame Mchiselwa. Mutsawashe Tembu. Ifiwe Tobose. In medical sciences, Nerik Bikraj. Melone Chiwocha. In microbiology, Nokubongwa Dlamini. Zoan Kumalo. Unarin Nemakwarani. Hagen Ogden. Slendile Shabalala. In physics, Jessica van Wyk. In plant science, Toriso Dioka. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science in Actuarial and Financial Mathematics. Cameron Curtis. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science in Agriculture in Animal Science. Johannes Jooste. Zwivuya Netsianda. Mr. Vice Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science in Agriculture in Applied Plant and Soil Sciences. Dipuo Mohanedi.
Let's give our graduates a big hand of applause. Mr. Dean, congratulations on the distinctions. I was watching very carefully that they are not handwritten, because some like to graduate distinction, so they write it when they're sitting there and say, I have distinction now. Congratulations. And I would now like to request our graduates to applaud their families and spouses and everyone else that supported them. Ladies and gentlemen, you've been a wonderful audience. We have now come to the end of the proceedings. And before we close, I invite you to outside here on the marquee tent, there's some liquid refreshments so that you can quench the thirst after many hours of sitting here. You are now requested to stand and remain standing for the singing of the national anthem. Thank you. By virtue of the authority entrusted to me, I now dissolve this assembly of the University of Pretoria.
Gaudeamus igitur, iurenes dum sumus. Gaudeamus igitur, iurenes dum sumus. Post iucundum juventutem, post molestam senectutem, nos habebitur.
Make today matter.